All right, we're going to try something out today. We're going to try this little mic. Yeah? Do I remind you of Justin Bieber? Perhaps? All right, so this is good. This allows me to walk around and do this, because I do this a lot, right? Okay, so today we're going to talk about the science of climate change. And I'm going to say something right now, that Al Gore was the worst thing to happen to climate change science. What? Is that what he just said? I just said that, okay? So Al Gore had a movie called Inconvenient Truth, where he got up on a scissor lift and started talking about the science. And one of the problems with Al Gore is he politicized the science. Okay, before this time, this is a picture of George H.W. Bush. He gave a talk in front of the Intergovernmental Panel on Climate Change, and he said, we all know that human activities are changing the atmosphere in unexpected and unprecedented ways. So something happened in the 90s and in the early 2000s that politicized this debate. So we can see this, this little cartoon here, showing scientists looking at climate data, thinking about the science, and politicians looking at opinion polls. And really, there's this divide. There's the science of climate change and the politics of climate change. And today, we're going to talk about the science. Okay, so what I want to do today is just give you an introduction about the science of climate change, and then think about some ways that you can make a difference, and then I'm going to open it up for questions. Okay, so why climate change? Why are we talking about this? Well, the all-school read, Ready Player One, kind of the central theme was the creation of the oasis was because we had destroyed our planet through resource extraction and overuse and climate change. So this kind of pairs well, this talk, with this book that we read. Okay, so we can ask a number of things, number of questions to help understand the science. And the first question is, kind of the obvious question is, well, is the Earth warming? And we can look at a number of things that help us determine that or understand that. So we can look at, for instance, air temperature over oceans, high in the atmosphere, low in the atmosphere, over land, near cities, in rural areas. And what we see is that various temperature measurements across the globe show an average increase in temperature of about 1 degree Celsius over the last 150 years. It's in really good agreement with each other. And so this is something that points to the fact that the Earth is warming. 1 degree doesn't sound like a lot, but as I'll talk about a little bit later, 1 degree can be significant. Okay, what's another thing we can look at to help determine if the Earth is warming? We can look at ice. Is ice melting? We can look at sea ice. We can look at glaciers and ice sheets. So here's an image of Antarctica, and we can see the melting of Antarctica over the course of the past decade. So this dark region shows where most of the melt is occurring. On average, we're seeing a decrease in ice mass in Antarctica. What's a little bit troubling to scientists is where it's melting in West Antarctica, we end up kind of creating almost a dam of ice. And if we start melting this at a rapid rate, we could potentially lose a lot more ice from the rest of the continent itself. We can look at mountain glaciers. So this is a mountain glacier in Alberta, Canada. And you can see this sign says the glacier was here in 1935. And you can see the glacier is no longer here. It's further up. So we're seeing glaciers, mountain glaciers across the world that are melting and receding. We can see a decline in sea ice. Here's the extent in 1980, kind of the where they measure it in the fall usually to kind of see the smallest extent. And now it's really just mainly above Greenland when they make these measurements in September. And so this can have broad implications with ecosystems. So polar bears, for instance, it's a kind of classic example. Where are they going to hunt and live with sea ice leaving? Okay, so is the Earth warming? Well, according to all the observations that we make, yes is the answer. Okay, so then the second question is, are greenhouse gases increasing? So greenhouse gases. Let's talk real quick about what greenhouse gases are. So the greenhouse effect is an effect that is just like in a kind of a greenhouse that we have down on the farm. Sunlight comes in, it hits the ground, and irradiates back as heat. And luckily, there are gases in the atmosphere, carbon dioxide, water, and methane, that traps that. If we didn't have that, we would be like the moon. It would be very cold. And so what can happen is this natural effect can be enhanced by the addition of these gases. And so the more gases, like CO2, that we have in the atmosphere, the more it's able to trap the heat. So are these gases increasing? Well, yes, they are. We can look at the Mauna Lea Observatory in Hawaii. It's a really incredible record here since 1960s. And we see this increase from about 320 parts per million. That's just a unit that we use. And we just surpassed 400 parts per million in recent years. And we see this increase over time. But that's just from 1960. What happened before that? Well, we can actually look at ice cores. This is my friend John, who's a glaciologist. He works in Antarctica. And he can actually look at basically trapped air over time. And so the little bubbles that you find in ice cores can be captured, and we actually can measure the concentration of carbon dioxide. And what we see is over the last 800,000 years, we can go back an incredible length of time, we can see the carbon dioxide has changed, but it's never gone over 300 ppm. So this is over time, we see this kind of not that big of an increase, but it wasn't until the Industrial Revolution that we get this major increase up to 400 ppm. So the data that we're seeing from the ice show us that CO2 has been increasing. Okay, so are greenhouse gases increasing? Yes, they are. So we've answered two questions here. So the third, and this is a great question to ask, well, is this excess CO2 coming from humans? Well, carbon cycle is pretty complex. We have respiration and photosynthesis that kind of cycle carbon dioxide. And so if we look at on land and in the ocean, we get this kind of balance. We get a lot leaving land and a lot being taken back up. Same with the ocean. Luckily, land and ocean are synced for that, so any excess will go into the land or ocean. But it doesn't take all of it. And what we can see is that there's no real way to take back the CO2 that we release from fossil fuel burning. And so this is what we're getting here. We're getting this increase in CO2 from fossil fuel burning. Another piece of evidence that we have is we know really well how much oil we consume, how much coal in terms of tons that we consume, and we can make calculations. We have an incredible increase since the Industrial Revolution of carbon dioxide. So is this excess CO2 from humans? It is. So really from all this, we can conclude that the data show that humans are causing climate change through the addition of CO2 from the burning of fossil fuels. So skeptics say, oh, well, there's no consensus on this. There's a debate. Well, in fact, 97% of scientists look at the data and conclude the same thing. So 97 out of 100 climate experts think humans are causing climate change. Now, one thing I would change here is to remove this word think and say conclude from the evidence. Because in science, there's no room for opinion. This idea of thinking and debating is really on the political spectrum. So science really points us to this conclusion. Okay, skeptics also say that the Earth's been warmer in the past, before fossil fuel. Okay, well, they're right. It has. It's been much warmer in the past. So back during the dinosaur days, things were much more tropical. Even at the poles, much more tropical and warmer. But the reasons for this temperature change are very complex, and they're attributed to volcanism, which contributes CO2, tectonics, which I won't get into, and changes with the sun. Okay, this is a big argument. Some people say, oh, well, it's the sun that's causing this, just changes in the brightness or intensity of the sun. We can look at data over the last 50 or 60 years, looking at the difference in the sun. This is the yellow. We're not seeing much change in the intensity of the sun over this time. What we are seeing is an increase in CO2, and this correlates well with the increase in global temperature. So a lot of these arguments that come forth can really, with thought, can be dismissed. Okay, so what's at stake if we don't curb this? Well, obviously, it's virtually certain that temperature will increase. That's what we've been talking about. And it's very likely that the number of heat waves will increase. It's very likely that we'll have more heavy precipitation events, flooding. It's likely that we'll have increased drought intensities and increase in sea level. Now, this is pretty interesting and shocking, actually, the first time that I saw a map like this. So here we have Boston. Excuse me. And the Charles River, we got Cambridge here. This is green because it's low-lying. Here's a building on Harvard's campus. And if we lose the ice that is expected to be lost on Antarctica by the early 2100s, so not too long from now, we could see an increase of 1.5 meters in sea level rise. So we can see a drastic increase over time. So let's go back and forth between these two. So you can see Boston, you can see the Back Bay, Fenway Park, probably right there. All right, so the blue is water. So this looks like it's going to be an expensive problem to solve. We can see the water on Harvard's campus going up. This is part of the NOAA website. This is something that you should explore. It's actually pretty interesting. Look at different parts of the coast to see what would happen. 1.5 meter sea level rise isn't too unusual prediction. It's definitely within the range of a lot of experts. Okay. So what can we do about this? Well, we can do this. We can put our head in the sand like ostriches. We can build the oasis like they did in Ready Player One and forget all about renewable resources and forget all about what we can do about climate change. We can all do that. Actually, this book was a cautionary tale about what not to do. It is your responsibility, and I'll emphasize this because this is our future. It might seem now, as teenagers, well, this is down the road. This is what your future is here. And it's your responsibility to keep learning science, hold our leaders accountable, dream big, and do small things every day. So science, keep learning science. Learning science, physics, chemistry, biology, environmental science. All these things are going to help you understand how science works. So when it's time to make decisions, you can fight ignorance with knowledge. The other thing is demand science-based decision making. Let's take the science that we have and use it to help make the best choices we can. Alternative energy is the future. Let's dream big. So Elon Musk is really the new Rockefeller. So instead of relying on fossil fuels as our basis to grow the economy and create wealth, let's do it through alternative means. And taking notes from Elon Musk would be a great idea. And then finally, do small things every day. It can be an overwhelming task. You say, I don't know what to do about this. Well, just flip off a light when you walk out of a room. That's all. Okay? You can carpool with these clowns. Maybe not. They're scary. But carpool. Carpool when you can. And then eat less meat. Try to reduce our carbon footprint. There are lots of things we can do. These are just a couple things, small things, right? If we do them every day, it makes a difference. So in the end, we have choices. We can bury our head in the sand, or we can wake up and see what the problem is. And what I suggest is we keep learning science, stay engaged with science, stay engaged with your politicians, and do small things every day, because it's your future. Thank you. Thanks.